Hi, I am Mohammed Imran, Professor of Communication Systems, James Watt School of Engineering, University of Glasgow. I am Dean, University of Glasgow UESTC, and I lead Communication Sensing and Imaging Research Group and University of Glasgow's 5G Research in Scotland 5G Centre.
Hello, everyone. I'm Kamar Abbasi, lecturer at James Watt School of Engineering. I'm also leading the connected healthcare and Internet of Things related use cases of Wave 1 Urban Project at Scotland 5G Centre.
Hi, I'm Sajad Hussain, lecturer at James Watt School of Engineering and lead of immersive training, a use case of Wave 1 urban projects at Scotland 5G Centre.
Hi, my name is Shujan Sari, and I'm a research associate at the James Watt School of Engineering at University of Glasgow. I'm also the 5G use case implementation lead at the Urban Wave 1 projects of Scotland 5G Centre.
Hello, my name is Kiadash Chipur, Research Associate in James Watt School of Engineering, contributing to Wave 1 Urban Project Scotland 5G Centre.
The University of Glasgow, founded in 1451, is the fourth oldest university in the English-speaking world, and it is currently ranked 67th in the world as per QS World Ranking 2020.
The James Watt School of Engineering was the first in the UK to confer degrees in engineering. Our civil engineering and electrical and electronic engineering are ranked first in the Scotland as per Complete University Guide Ranking 2020.
Scotland 5G Centre was established by the Scottish Government for the adoption of 5G use cases for the social and economical development of Scotland.
5G is not just a new mobile technology. It is an ecosystem that brings together advanced internet features and wireless technology to provide futuristic applications that we only imagined or we only saw in sci-fi movies so far.
In UK STEM Academy, we will conduct some collaborative activity that allow you to understand 5G and its application.
We welcome you to the UK STEM Academy and wish you an enriched learning experience. University of Glasgow welcomes future world changers.
Are you ready?
Are you ready?
Are you ready?
So very briefly introducing University of Glasgow, it's one of the top 100 universities in the world with a very large size cohort of students here, with several Nobel laureates connected to the university, and the university standing second in the Russell Group for teaching, as well as top 30 most international universities in the world. The university was established in 1451 and has a rich history as well as a glowing present as well, with 95.9% of our students in employment or further study within 6 months after graduation. So in this short discussion, we will be presenting to you how information is communicated from one point to the other. And we will ponder on this question: how data flows from one mobile phone to another. So imagine that you are in Glasgow and you want to communicate with some relative in Orkney Islands, a far off place within Scotland. And this communication you want to do through your mobile phone. So how your information gets converted into a suitable format and communicated to the final destination. Imagine you are sending this picture, people make Glasgow, with an image associated with it, text and image, over to Orkney Island to be displayed on another similar device, either a tablet or mobile phone. So first step is to convert the textual information into a suitable mathematical format. We call it digits or binary digits, or in short, bits. Bits are a sequence of ones and zeros. And why we use ones and zeros? Because they can represent two diverse, easily distinguishable states. For example, switching on or off of a switch, switching on and off of a light. So you can go back to a historic communication method, which was by signaling light or fire to send messages or signal to far off places. So if something is on, that could represent a 1. If something is off, that could represent a 0. And a simple yes or no or a binary message could be communicated. But it has more power than just sending yes or no messages, because as we will see, these sequences of ones and zeros can encode a much richer set of information. Taking this example of the textual message, the word people, it's made up of characters, P-E-O-P-L-E. Each of these letters or character is actually encoded using a sequence of ones and zeros, 8 bits long. And this is unique to represent P, another unique sequence to represent E, and so on. This generates a longer sequence of ones and zeros to encode the word people. And same thing happens for make, and same thing happens for Glasgow. So people, make, Glasgow can be represented in its binary form with a sequence of binary digits or bits. Similar thing can happen with the image as well. So image is made up of lot of smaller and smaller pixels. So if you keep on focusing on, you can get to the minimum or smallest building unit, which is a pixel. A pixel can be represented with its constituent colors, red, green, and blue, and each one of that color or the intensity of that color is actually represented with an 8-bit sequence. We also call 8-bit sequence of binary digits or bits as a byte. So 24 bits for 1 pixel or 3 bytes for 1 pixel. Now coming back to our scenario, so information from this text and image message is converted into a sequence of ones and zeros, and this has to be transmitted from the city of Glasgow to Orkney Islands. So you have a mobile link, wireless link, plus a wired link in between Glasgow and Orkney Island. So your mobile sends a wireless signal encoding these ones and zeros into a suitable electromagnetic radiation or wave. For example, light itself is an electromagnetic radiation of wave, but radio waves are similar to light, but our eye cannot see them, but they can carry messages for us. So mobile sends this through a wireless wave to the tower. Tower then sends it through a network of different nodes, these switching centers. So just like a letter, postal letter is communicated from one place to the other, and in between it goes to different sorting and posting centers from where it is routed to next destination. So finally, this electromagnetic signal encoded in ones and zeros reaches Orkney Island tower, and from the tower again a wireless signal is transmitted down to the other device and your message is conveyed. So I will conclude this talk or brief introduction of bits and bytes with some activity at the end, and I will give you some hints or some suggestions how to complete this activity. First, on the left hand side, you will look at the question on filling in the following boxes with the typical data sizes in megabytes. So this is a question of your experience so far dealing with large files like movies, smaller or medium-sized files like music, and finally a video chat. So if we put a duration of video chat equal to 1 minute, you can estimate exact amount of megabytes to be generated during that video chat. However, if I ask you to focus more on the rate or amount of data per second that is generated by video chat, this question will become even more interesting. Now, the second question is regarding a picture with 4,000 pixels. And the question is, what will be the size of the picture in megabytes? So you have to first know that 1 pixel is 24 bits, which 8 bits is 1 byte. So you can calculate how many bytes it will mean. And then you have 4,000 pixels. So you multiply with this number in order to calculate the overall number of bytes in the data. Now, the question is how much time it will take to transmit this simple picture of 4,000 pixels. We have calculated how many megabytes it is. Now you know that a 2G signal or 2G communication technology can transmit 0.3 megabytes in 1 second. The question is how much time it will take to transmit exact number of megabytes that you have just calculated as an answer to question 2. Repeat this for 3G, 4G, and 5G, and you will see that how drastically the time taken to transmit this reduces. In the next question, this is repeated for a much larger file size of 4.2 gigabyte. The procedure is exactly same. One piece of information to note is that 1 gigabyte is actually 1000 megabytes. And finally, how much time can you wait for downloading a movie of size 4.2 gigabyte from your experience? With everything becoming so fast and we being spoiled with the power of technology, your answer could be a few seconds, but you have to think about what will be an acceptable duration to achieve this, and will 5G meet your expectations? Thank you very much for your attention, and I will stop here. Thanks.
Hello, everyone. Up to now, you have learned about how an information is transferred wirelessly from one point to another point. And then you have learned about the composition of an image, which is pixels, and the composition of pixels, which are bits and bytes, and then those bits and bytes are converted to electromagnetic signals to be transferred from one point to another point. And now we will talk about immersive experience, which is one of the key experience we get from 5G. So immersive experience is an experience which brings you to the reality, and you feel like you are inside that scene. And this can only be made possible through a feature of 5G, which is enhanced mobile broadband. Now, the first thing is, what exactly is broadband? So you have learned that basically that how you can send an information of a single user from one point to another single user on another point. But how about if you have multiple users at transmitting side and multiple users at receiving side? So this brings a concept of broadband. Basically, broadband is a high transmission technique which enables a large number of messages to be communicated simultaneously. And this brings us to the concept of bandwidth and data rate. These two terminologies are used interchangeably. So in order to understand bandwidth and data rate, let's take an example of a water tub, which we want to fill. And we want to fill it through a water which is provided by a pipe. So in the first case, you can see that we have a thin pipe. And if we want to fill a water tub, it will take a bit longer. In the second case, we have thick pipe. And you can see that in this case, it took lesser time as compared to previous case to fill the water tub. And in the final case, the pipe is thickest and it took a shortest time among all to fill the tub. Now let us consider this analogy for mobile communication. Now think of this tub as a mobile phone, the water as a movie, and the pipe as a mobile network. And you can see that basically first case can be linked to 3G, where you have seen that it took the highest amount of time to transfer the water, which will be basically it will take highest amount of time to transfer a movie to mobile phone if we are using 3G. The second case can be considered as 4G. And the 5th case is actually 5G, which took even a blink of eye to transfer all movie to the mobile phone. So there are so many applications of enhanced mobile broadband. Think about this live sports and training. So 5G with its enhanced mobile broadband capabilities can let us watch the sports in an immersive experience where we feel that we are actually watching sports live and doing live training. And then augmented reality and virtual reality immersive experience is possible through this feature of 5G, where you can have online gaming with an immersive experience. And lastly, ultra high definition video streaming with 8,000 pixels. Imagine that you have seen in the previous scenario about 24 pixels. Uh, Here we are talking about 8,000 pixels. So you can imagine that you will be feeling like you are watching something by uh, basically sitting inside that scene. So these all features uh, are enabled by enhanced mobile broadband. This is your activity sheet. You have learned about enhanced mobile broadband. Now I want you to doodle or draw three new applications from your daily life that you think will require 5G data rate. Thank you.
Hi. So now that we have learned something about bits and bytes, bandwidth and data rates, let's have a look at another feature of 5G communications, which is about instant connectivity. And this is about ultra reliability and low latency communications. That is, not only what we are sending reliably reaches at the destination, but also reaches well within the time bounds. To explain this, let's have a look at a very simple example. Imagine on a Christmas Eve, your grandma all of a sudden remembers that she forgot to send you a gift. So she wants to send you a gift. Let's have a look at what options she has. In olden days, the postal services used to be carried by the carriages as shown in this figure. And then we have some second class Royal Mail services, first class Royal Mail services. Let's see how it will work with the delivery if we use the old carriage system for the delivery. And it will take a lot of time, and your grandma's gift will reach you somewhere in the next year. If you use this the second class, you might reach it, it might reach you on the New Year Eve. But if the first class services, the same day delivery services are used, it will reach you on the Christmas day. So we see that with the different services, the time for our gift to reach the destination is different. In terms of communications, if we make a comparison between different communication standards in third generation of mobile phones, the typical delays were around 200 plus milliseconds. For 4G, it was 50 to 100 milliseconds, and 5G has further reduced it to 1 to 4 milliseconds. What impact of this reduced delays will be on the applications? Let's have a look at some of the use cases. Remote robot control. So we can control the robots remotely for doing any sort of job that we want them to do in the industries, in the military operations. But it is important that we are able to communicate our command signals to the robots in a timely and reliable fashion. Another use case is remote surgeries, where the surgeon in Glasgow can remotely control a robot somewhere in the Highlands to operate a patient, But in this case, the reliability is extremely important. You can well imagine if the communication between the surgeon in Glasgow and the robot in Highlands is not reliable, lives could be at risk. And finally, self driving cars. When self driving cars are on the road, it is very important that they communicate with each other reliably and within specific time bounds to avoid the accidents. So these are some of the use cases about instant connectivity. And technically, we call it ultra reliable low latency communications. Now, let's have a look at the activity sheet. This relates to ultra reliable low latency communications. First, we request you to write or doodle or draw 5 examples from your daily life that you think latency in the communication is very critical for those applications. You may use some extra pages if required, right? Then we want you to write 3 social and economical impacts of 5G ultra reliable low latency communications. What could be the impact on the social life and what would be the economical impacts? And finally, what do you think could be the 2 ethical and security concerns about 5G ultra reliable low latency communications? I know these questions are a bit hard, but you need to think, and I am very confident you will be able to crack some nice answers for these questions. Here are some resources that you can take help from. Thank you.
Hello everyone, my name is Shuja and I'll be going over the third important aspect of 5G. So far you've learned about digital communications, you've learned how text and images are broken down into bits and bytes, converted into electromagnetic waves, and then sent over from one place to another. Then you went on to learn about the first aspect of 5G, which is enhanced mobile broadband that lets you achieve higher data rates. And then the second bit was on ultra reliable low latency communications. That's to do with when you have to send a message from one place to another, how quickly that message should be sent. Now, the third most important aspect of 5G, which tends to combine a little bit of mobile broadband with a little bit of ultra reliability and low latency, is the massive machine type communications. The idea behind massive machine type communications is that it's for everything. It's there to connect everything together. What do we mean by connected everything? An example would be a connected washing machine. Imagine you just keep loading your clothes into the washing machine on the go, and when the machine figures out it's full, or when you want it to run, you send it a command or tell it to start over the internet through your mobile phone or through your iPad, and it starts to do that. Another example is a smart fridge where, for example, your favorite ice cream is running low. It tends to figure out that your favorite ice cream is running low. It'll send a notification to your parents or to you, or it can also send a notification to your nearest supermarket, which then automatically delivers your favorite ice cream to your home. How cool would that be, right? Other examples could be our other appliances at our home that could be connected to the internet and become smarter. Could be a smart TV, a smart lamp, or a smart watch. The idea behind a smart TV would be if you tend to doze off while watching your favorite movie, the TV would figure it out and switch itself off or pause the movie where you dozed off. Think of the amount of energy that we would have not wasted. Further examples and applications of massive machine type communications. We've got the Internet of Things, where when we connect anything to the internet, for it to be controlled over a wireless link or even a wired link, that thing then becomes part of that Internet of Things. And 5G's massive machine type communications is to address that connectivity that these Internet of Things would require. The second example could be simple looking at how much power or energy you're using on the go. Already we've got in our houses, most of our houses have smart meters in them. And these smart meters talk to the smart grid over wireless links. But as we're progressing to add more and more smart meters into our society, there will be a capacity block. And 5G, again, with massive machine type communications, is there to address this capacity issue, to enable more and more of these devices connected to the internet. And then we've also got a smart city. When we get things talking to one another, if we have cars and ambulances and all those entities within our city talking to one another, they tend to be more cooperative. And when we have cooperation among ourselves, we tend to be more smarter. So imagine if we have all these different entities in our cities talking to one another, cooperating with one another, we would have smart city, and 5G's massive machine type communication is there to enable this kind of connectivity between all these different things in our cities. Finally, we've got an activity sheet for you. The first question in this sheet is list the things at your home that you think that can be connected to the internet and will eventually improve your life by connecting to the internet. We've got 10 lines. Feel free to fill in as many as you can. And once you fill those in, the second question relates to that. Now, what do you think would be the main three main challenges with the implementation of massive machine type communications for the examples that you've just spoke about in the first question? So you would see how first and second are quite related. Moving on to the third and last question, we've given you a couple of scenarios and we want you to think how 5G, Internet of Things, or massive machine type communications can help in these two scenarios. The first scenario is of a student at home. You must have seen over the past 3 months, most of us who are sitting at home, and internet has been a real help for all of us. Maintain our work, maintain our social activities, and all of that. So how can a student sitting at home take advantage of 5G and Internet of Things? The second scenario is of a lost child. How do you think 5G and Internet of Things can help a child lost in a supermarket or in a fun fair or in a circus? How can IoT, Internet of Things can help this boy? Next, we've got some resources for you. The first one is how 5G's IoT is offered by Ericsson. And the second is 5G and its impact on Internet of Things. This is just simple reading resources that would make you think about different applications and different examples that you could possibly add into your activity sheet. I hope you enjoyed this session and see you later. Thank you very much.
Hello, my name is Kia Dashtipur. I'm a research associate in James Watt School of Engineering. Today I'm going to discuss about artificial intelligence and machine learning. What's it, machine learning? Machine learning is an application for artificial intelligence which provides to make the system automatically learn and improve from the experience without explicitly programmed. Machine learning focuses on the development of a computer program that can access the data and use to learn it themselves. Sometimes it's referred to machine code or object code. Machine language is a collection of binary digits or bits that the computer reads and interprets. Machine language is the only language a computer is capable to understand. In addition, the exact machine language for a program or action can be different from operating system on the computer. The specific operating system will dictate how compile writes a program or action into a machine language. Um, For example, um, just to give you a brief example of machine learning in your daily life, just imagine you have forgotten your uh, phone password. Guess what? You don't need to remember your password anymore. With the face recognition, which is already installed in most of the new mobiles, so you don't need to remember or memorize your password anymore. Do you ever wonder how Alexa is working? Uh, in this slides, I'm going to discuss how AI and some of the application and AI and also machine learnings. The machine learning can be used in the face recognition. For example, it can be used to detect the faces. Also, it can be work in the number plate recognition. And also it can be used in robotics to do some homeworks for you. Uh, we created a task sheet for you so you can do some task for us. In the first task, you have to give 3 examples where artificial intelligence and machine learning can improve uh, your quality of life. And the second question, name some type of sensor which it's help you to require and realize the artificial intelligence in the example above. Thanks very much. You can use these resources as well to help you to answer this question. Thank you.
University of Glasgow welcomes future world changers.